Hey everybody, I'm meteorologist Gavin Sandell. Well, winter forecasting, it's tough. The jet stream gets super volatile, making predicting old man winter much harder than any other season. One way we can attempt to do this is analog forecasting, looking at how conditions in the present have compared to similar ones in the past. And one way that almost all of you guys know as an analog forecast is ENSO, the El Nino Southern Oscillation, with its two phases, El Nino and La Nina. Currently, we're in a pretty weak La Nina, meaning sea surface temperatures are a little bit cooler than average just off the coast of South America. And that's because trade winds going from east to west have strengthened just a little bit, making that ripple effect and the top of the sea surface a little bit more disturbed. In the case for our region, we don't get too much of a difference in temperatures in past years, but the one thing that we see in La Nina years, we're a little bit more wetter than average. So that's just one of 5 that I'll be talking about, analogs, and they go from all places of the world. We saw that one in the Pacific, we'll see one in the Atlantic, the Indian Ocean, and we actually can go all the way up in the atmosphere too, to the stratosphere, over 10 miles above our heads, and talk about the winds. The stratospheric winds above the equator determine the quasi-biennial oscillation, and this is a cyclical change in the winds about every 14 months or so, and when you get in the westerly component, those winds coming from the west, it increases the chances for mild winter weather in our area. Switch the direction, switch the result. If you go from the east, it increases the chances for cold winter weather. So this year, we're actually in a very strong easterly component. At least we are as of right now. We'll see what happens towards the end of winter. So in this terminology, we are favored to have a cooler than average winter. Not so much in terms of precipitation, though, at this stage. So now I'm going to put a scoreboard down because we're only 40% of the way there. Once we get into the Atlantic Ocean, we could look at the Atlantic multidecadal oscillation. And this is a very slow but cyclical change of Atlantic sea surface temperatures from below average and then back to above average. Since 2000, we've been in the positive stage where we've had a generally above average temperatures in the Atlantic Ocean. And when that happens, winters here are favored slightly warmer and wetter. Compare this to the negative phase where it still will be slightly warmer as we've seen in the past, but there's not too much in terms of precipitation that we'll see generally equal chances. So because we're in the positive phase, we'll add this one to the scoreboard, warmer and wetter than average. And now we'll go to the Pacific Ocean, to the Pacific decadal oscillation, which typically kind of runs along the same lines as the Atlantic, except we'll split it into 2 regions rather than just one. Off the Pacific coast of North America, in the positive phase, waters get a little bit warmer than average compared to if you go further towards the west where they're cooler than average. And the phase that we're currently in right now, the negative phase, this has been the case for about 7 or 8 years. Waters off the Pacific coast are cooler than average, and then towards Asia, they're warmer than average. And in that case, warmers are wetter and warmer as well. So this will be the exact same thing as the Atlantic multidecadal, the AMO, and we'll put that in as warmer and wetter than average. So now for our last one, we'll go to the Indian Ocean here. This is the Indian Ocean dipole, kind of the same lines as the Pacific decadal oscillation. And when it's positive, waters over to the west are warmer, east to are a little bit cooler. Winters here, there's actually not too much favorability in our area, but the phase that we're in right now, the negative phase, you could see cooler to the west, warmer to the east. Winters are slightly warmer and drier here, so we'll add that to the scoreboard here. Warmer and drier. So there's a lot of things that are going on here. All 5, you have to combine them in some way. And what we do, really the punchline of analog forecasting, is looking at similar years that we've seen in terms of what we just saw. And this is what we come up with, the best 8 years. And generally we see a trend of above average temperatures and below average snow. Actually, when you combine all of these 8 years, the temperature is 3.5 degrees above average, the snow just shy of 9 inches below average. So what these analogs are showing us is that it'll be a warmer than average winter and a drier than average winter as well, in terms of snowfall though. But analog forecasting is just one way Chief Meteorologist Eric Wilhelm is predicting winter. To see his brand new winter forecast, check out the WFMJ website and YouTube channel for more. For Weather 101, I'm Gavin Sandell.